Hi and welcome to the next video of section 3, Health. In the previous video we've learned about bounds locking. In this video we'll learn more about health. Both the player spaceship and enemies need health. Health is a measure of a character's presence and legitimacy in the scene, typically scored as a value between 0 and 100. 0 means death and 100 means full health. Now, although health is in many aspects specific to each instance, the player has a unique health bar, and each enemy has theirs. There are nevertheless so many things in common in terms of behaviour between player and enemy health that it makes sense to code health as a separate component and class that can be attached to all objects that need health. This code should be attached to the player and all enemies or objects that need health. The health class maintains object health through a private variable _health points, which is accessed through a C# property, health points. This property features both get and set accessors to return and set the health variable. The health points variable is declared as serialized field, allowing its value to be visible in the inspector. This helps us see the value of the player's health during runtime and debug and test the effects of our code. The health class is an example of event-driven programming. This is because the class could have continually checked the status of an object health during an update function, checking to see whether the object had died by its health falling below 0. Instead, the check for death is made during the C# property set method. This makes sense because set is the only place where health will ever change. This means that Unity is saved from a lot of work in each frame. That's great performance saving. Health class uses the sendMessage function. This function lets you call any other public function on any component attached to the object by specifying the function name as a string. In this case, a function called die will be executed on every component attached to the object, if such a function exists. If no function of a matching name exists, then nothing happens for that component. This is a quick and easy way to run customized behavior on an object in a type-agnostic way, without using any polymorphism. The disadvantage is that sendMessage internally uses a process called reflection, which is slow and performance prohibitive. For this reason, sendMessage should be used infrequently, only for death events and similar events, but not frequently, such as every frame. More information on sendMessage can be found at the online Unity documentation at this site. When health falls below 0, triggering a death condition, the code will instantiate a death particle system to show an effect on death if a particle system is specified. More on this shortly. When the health script is attached to the player spaceship, it appears as a component in the inspector. It contains a field for a death particle prefab. This is an optional field. It can be null, specifying a particle system to be spawned when the object dies. This lets you create explosions or blood spatter effects easily when objects die. Great! We've successfully learned about health. In the next video, you'll learn about death and particles.